Okay, welcome back, and today we're going to start talking about derivatives of inverse functions. So I'm going to start by doing this graphically, and then we'll also show this algebraically too. But if we look at a function here, and then, so this is the inverse function and this is the function, and we take a point a comma f inverse of a, and let's assume that f of x is invertible and differentiable, then it seems reasonable to believe that the inverse function will also be differentiable. And so if we look at this point here, a comma f prime of a, and we see the tangent line here, notice that the inverse of this, now instead of using f as, and what this point is, because this point isn't going to be exactly, it's going to be a different point in the coordinate plane. So what we're going to do is let's identify this point by realizing that this point is just going to be the ordered pair here, but switched. So this ordered pair is going to be f inverse of a comma a. Okay? And this tangent line is going to be represented by f prime of f prime of f inverse of a. Okay? Okay. Or no. Not that one. Hold on. This is going to be prime of a. And then this tangent line will be, because this is a, so this is going to be the tangent line at a for this one. And so it'll be f inverse prime of a, because that's what we're taking the derivative. So it's the derivative of this function at a. So that's why this one. This one is going to be f f prime of f inverse of a. Because this f of x is actually the inverse function, right? So it's actually evaluated at this point here. So that's why we go in here. So it's f prime, but it's evaluated at this point here. So it can be a little confusing, but just realize that we're defining the inverse based on this point here, based on this inverse function here. Okay, so here's f of x. Here's f of inverse of x. Here's the point a comma f inverse of a. So here's the point f inverse of a comma a. So we just switch the points. This tangent line is the derivative of this function. So it's evaluated at a. So we would say f inverse prime of a, because it's the derivative of this function. Now if we look at the f of x, because we're doing everything at this point here, this point is f inverse of a comma a. So this is our x value, this is our a value, quote unquote a value. So this is going to be, this tangent line is going to be the derivative of f of x, but evaluated at f inverse of a. So that's how we get this expression here. Okay. Now notice also, because they're inverse functions, I have the line y equals x, and the only, I put that there so you can see that they're inverses of each other. Okay, now, from this graph, we can see that this tangent line has a slope of p over q. And the slope of the inverse tangent line is q over p. Okay? Notice how this also inverts as you reflect across y equals x. Okay? So it's reasonable to believe that what? Well, then the derivatives will also be inverses of each other, or invertible. Okay, and so what do we get? If we take this tangent line here, and the fact that these two triangles, because if this is P here, this is P here, if this is Q here, this is Q here, and so what do we get? We get that F inverse prime of A would equal 1 over f prime of f inverse of A. Right? Because obviously from here we have this is equal to P over Q, and this one is equal to Q over P. Okay? Now, we could also derive this algebraically, because if we look at composite functions, because remember, inverse functions, right? If you have inverse functions, you can compose them and you can get x back out. So what we know is that f of f inverse of x equals x, right? If we have two inverse functions. Okay? Now if we want to take the derivative of this, right? We have to use the chain rule. So if we take the derivative of this with respect to x, we get f prime of f inverse of x times f inverse prime of x equals 1. And then all we have to do is just divide both sides by f prime of f inverse of x and we get the result. Okay, and then of course we just put in a when we want to take the derivative at a point A, but this is the derivative function. So we could do it algebraically too, and show that we get the same result. Okay, that f inverse prime of x is equal to the reciprocal of 1 or 1 over f prime of f inverse of x. And that's it. Have a great day.